join today. This time, we want to talk about how to reduce electricity and gas costs in foundries thanks to innovative products such as coatings, additives, and fitting system technologies. First of all, I would like to introduce to our speaker, Mr. Reinhard Stochel, our global expert in coatings and additives. Reinhard is from Siegen and he has a PhD in organic chemistry. He gathers a lot of knowledge and experiences in his long career in the foundry business. In fact, this is his 40th anniversary dedicated to this great sector. Since 2016, he is in the ASK Global Expert for Coatings and Additives, and he has like two favorite products, in this case coatings, which are the Velvacoat IM801 and the Solitec IM801. We are lucky to have Reinhard in the ASK team, and I am pretty sure that you will find very interesting and useful information in this session. Please allow me to introduce myself very briefly, as I will participate in this webinar together with Reinhard. My name is Imanol Ortiz, and I am a technical product manager of the Feeding Systems team. And since I entered in ASK 7 years ago, I have been dedicated to the risers and filters product lines, giving support to foundries in Southwest Europe. We both hope to meet your expectations for this webinar. But before we start, there are some things to know about how this event works. The protection and personal data is our top priority, so no names, pictures, or avatars will be displayed at any moment. There is also no audio or video connection available from your side. Nevertheless, you can ask questions at any time. These can be written in the chat box at any moment. We will try to answer all questions at the end of the session in the Q&A section. Should any of these questions not answered due to time shortage, we would be pleased to answer them personally afterwards. A recorded version of this event will be available for you in the following days. And so far, this is all from my side, and now I switch to over Reinhard Stotzel.
Also, a warm welcome from my side. We would like to structure the webinar in following steps. First, I will tell you something about the rising energy cost and how the energy is distributed. Then, how we can save energy in the coating process, followed by savings with additives. And later on, Emmanuel will tell you something about mineralizers, filters, and finally a conclusion. What is the consumption of the energy in the foundries? Certainly, the melting takes the majority of the energy. If we have the iron and steel foundries, it's about 1,000 kilowatt hours per ton of molten metal. And then in steel foundries, we have a big chunk of energy for the heat treatment, which is about 500 kilowatt hours per ton. Furthermore, we have ladle heating, molding, fettling, etc. In another literature, it is reported about the total energy and split it into electric power and gas. Iron foundries, due to that, have a consumption of 900 kilowatt hours per ton electric power, whereas steel foundries have about 2,400. And gas consumption in iron foundries is about 40, whereas in steel foundries it's 10 times more, 350. What's about the core shop? For the coating drying, when we have hot air convection ovens, we need a gas consumption of about 280 to almost 500 kilowatt hours per ton of sand cores, whereas if we have microwave drying, the electric power is only about 60 kilowatt hours per ton. What is the development of the energy prices? If we look on the electricity prices in Europe of the last, let's say, 20 years, you can see that continuously the prices have been increased. But what is more frightening is really the gas prices, which exploded beginning with 2021, really through the roof. And this is a big problem for all energy consuming industry, but especially, of course, for you as a foundry. But nevertheless, when a problem appears, typically the motivation and willpower increases to solve these problems, and there's a light in the tunnel. There's a new process in place which is called ORC, Organic Rankine Cycle Process. Here you can make use of your waste heat in the foundry. You have a heat exchanger where an organic component like ethanol is inside, and it is heated up by the waste heat from your melting shop or your cooling station. Then this ethanol vapor pressure run a turbine and produce electric power. And this is quite high yield of 17 to 20% already. So this is really good news. And the thermal yield is already at 60 to 70%. So you can make use for heating your buildings or running your drying oven, or even have a grid with your neighbors. What can we do in the coating drying process? The basic parameters for the drying is definitely the sand type, which means the heat capacity and heat conductivity of the sand. Furthermore, we have the coating solid content, which equals to 100 minus water content, which means the higher the solid content, the less energy you need for drying. Furthermore, the water retention of the coating. The less the water soaks into the sand, the less energy you need for drying. Of course, the amount of applied coating is important, the drying temperature and time, air velocity and humidity, and as already mentioned, the drying equipment, if it is convection, microwave, infrared, vacuum, etc. We define the performance as drying speed and energy cost per kilogram coating for drying, and this has to be optimized with the above mentioned parameters. How do we know that the coating is dry, which is very important for the casting result? There is equipment available which is typically used in construction industry. For instance, this hydromet. We know that if the reading is below 40, we are sure that the casting is good enough and dry enough. The other possibility is to scratch off the coating after the drying oven, put this powder in a laboratory and detect the remaining moisture with the drying balance. And there's another way to have a color change moisture indicator. You see on the bottom left side, the US coating, which is in the wet stage, pink, and change to yellow if it's dry. So as soon as you have not any more pink spots on your mold or your core, you can be sure that the coating is dry. In Europe, we have a change from black to gray, as you see, and this is also a very good indication. However, you have to take caution. For instance, if you want to reduce your drying temperature to save energy, you must have in mind that cold box resins often contain low volatile solvents, which then remain more in the core and may provoke gas defects. So in any case, prior to a decision, you have to do casting trials to avoid any trouble. What about the drying parameters, air velocity, temperature, and humidity. If you have a look on these curves, you can see that the low air humidity and the high airspeed is much more important than a high temperature. Why is that? The drying is a two-step process. You have the heat exchange and you have the mass transfer. Only as the water vapor is removed from the coating surface, the drying is continued and not stopped. That means when you have low air humidity and high airspeed, the moisture is eliminated and you may be capable to reduce your drying temperature. If this could be possible with your ovens, then you can directly calculate how much energy you will save with a Molly diagram, which you see on the right side, to find out how much energy you consume less with a lower temperature. There's another way to save energy in the drying process, which is to make use of waste heat in case that you use a dehumidification. Here is a principle shown on the right side of the Münter's desiccant rotor principle. You have, with the blue arrows, the process air, which runs through the desiccant. The moisture out of the air is removed, and the dry air is fed into the drying oven. On another place of the rotating desiccant wheel, hot air from waste sources like melting shop or other sources are fed into the desiccant wheel, and the desiccant is reactivated. This has been shown to work really perfect. We have an example of a foundry which is producing counterweights, and they coat the mold with a Solitec WP41 at a temperature of 6 degrees with a dehumidified air in only 20 minutes. And the heat, which is from the melting shop, is for free. What about the different kind of coatings? Here you see on the right, on the left graph, the orange curve, and you can see that the drying is finished after 30 minutes. And there are other coatings, for instance, with the blue bar, the Solitec ST901, the drying is already finished after 15 minutes. So that means you save 50% of your drying time. This you can use to reduce, for instance, your drying temperature again and save, as already described before, energy. And it has been proven that this fast drying coating is capable even to be substituting alcohol-based coatings in a drying oven. What kind of different fast drying coatings do we have in our portfolio? On the automotive iron castings, we have the Maratec TS520 and MB401. And for inorganic binder systems, which are really sensitive against water, we have the Maratec IBS 703. For iron Novec foundries, we have the Solitec HI 704 and WP41. And for steel Novec castings, we have the already mentioned Solitec ST901 and the Circon-free ST801. What's about to eliminate the coating process in total? This we can do with sand additives. Typically, sand additives are used to prevent casting defects, for instance, veining, which is often a side effect of the cold box bonded cores, but also to stabilize the casting production in general. But there are more reasons for these novel additives. One of them is to have a coating-free production under certain conditions. There are different kind of additives available. It's the organic ones, which we call Bueno, the inorganic, which we call isocil, and the hybrid additives, which we call Bueno Ultra. All of these have different feasibilities for application, some advantages, some challenges, also different addition rates. I would like to focus on the hybrid additives in this presentation. Hybrid additives are a mixture of organic and inorganic raw materials, and they have a high cost saving in the process cost. They have the opportunity for coating-free production. By this, you can reduce your investments in maintaining or reinvesting in drying equipment, and you have the additional effect that you can replace or reduce expensive special sands. They are suitable for iron and steel castings, especially for brake disc, brake caliper, hydraulic parts, engine blocks, and cylinder heads. And I would like to show you now an example. This is a ductile iron casting, a wheel part of a truck, originally coated, and we could eliminate the coating process by implementing the additive Bueno Ultra. And even on gray iron casting, we were capable to show that this concept works. Here's a housing of gray iron grade 250 with 120 kilogram weight, originally coated, and now the coating process has been eliminated by the additive EP4874. What kind of cost savings could we achieve? If we consider the process with the coating, you have the cost for the coating itself, which is a dark pink bar, and you have in addition the coating preparation and the coating drying, which is the orange bar. So you need manpower for the preparation and you need energy for the drying. If we set this to 100%, and if we change to a coating-free process with implementing the additive EP4874, the blue bar, we can save more than 35% of your cost. I now hand over to my dear colleague Emmanuel.
Thank you, Reinhard. So now we will go through the mini risers as another innovative product to also save and optimize energy costs. So we have here, for instance, one example of ExactCast Kim, one of the products in our portfolio that help us to optimize the feeding system's volume as we keep an external shape like the insertable key A, but we reduced the interior volume. This means that we have like a more thicker wall of exothermic and insulating material that with less volume inside of metal, we can keep the same module and the same performance. This change of saving kilograms of metal inside of the riser will also give us these energy savings. Approximately when we change from a standard insertable sleeve 4/7 into a Kim 4/7, we can save approximately 0.3 kilowatts per riser. If we look at these charts, we try to show all these comparisons between the regular insertable sleeves compared to the Kim version. In terms of weight, we can see in these curves the difference in terms of volume weight, and also in terms of savings. We have to say that this change, this reduction of volume in these risers, are always taking into account that we keep the module, so the performance is not affected by this change. Now we will go through some case studies, some examples to see how we can achieve these savings with different products. In this first example, we can see a KIM application in which before the casting, in this case a ventilated track brake disc, had insertable sleeve 6/9, sorry, with 3 kilograms per sleeve, and changing these risers into the KIM version with 1.6 kilograms each, they were able to save 4.5 kilograms per casting. So this meant 4.5 kilowatts of energy saved. In the second case study, we have a steel casting with an original design consisting of traditional fiber TA6 and cylindrical neck-down risers, 6 positions in each casting, and the volume for each fitting solution was 5 liters. And the proposal from ASK was to use the KNV XL 2565 with 2.5 liters each, giving the result of 120 kilograms savings of steel per casting. And the good thing for this customer was that with the same ladle, he was able to pour one more casting of this regular one plus 2 small ones. So the furnace capacity was really optimized. And in the end, again, the energy savings were also about 120 kilowatts. In this third case study, we are talking about a super duplex casting, a special alloy in which the original design consisted of, again, traditional fiber solution, atmospheric plus cylindrical sleeves with a volume of 4.5 liters. And the solution was again to offer the KNV 2565, achieving fitting savings of 45%. In the end, the reduction on kilos, 48 kilos in this case, meant also energy savings, of 48 kilowatts per casting. Here we have again one steel casting. In this case was a stainless steel part with an alloy with chromium and nickel. And the gross weight of this casting was 370 kilograms. And applying the solution from the KNV XL risers, we were able to reduce the total weight, the gross weight of this casting to 272 kilograms, and the yield of this casting improved from 40% to 55%. And the foundry was able to save around 100 kilowatts per casting. In this example, we are talking again about a steel casting. This was a kind of manganese steel ring with 10 position of risers consisting of neck down with 90 kilograms each. And our proposal to change into the KNV XL solution was the result of saving almost 700 kilograms per casting with our reduced volume risers. And in the end, the foundry was able also to save around 700 kilowatts per casting. Not risers, but now filters is also one of these top products that also can help us to reduce this energy cost. We are talking now about the exact fill, a tubular filter, in which we can have big yields of savings compared to other traditional filtration systems with similar capacities. We can have a residual metal with this system about 140 kilograms compared to these traditional solutions that can reach up to 245 kilograms. These tubular filters can have a maximum capacity of 10 tons. And in the end, we can save, apart from these volumes, also 100 kilowatts of energy. Here we can see more or less the three parts that consist of a exact fill filter. We can identify the two parts of the housing, the upper and the lower part, and the filter itself. And we can see more or less the performance of it. We can identify one entrance, if you look at the picture on the top right side, and two possible exits. So the conclusions of this webinar today about how to reduce energy with these products. Let's remember about coatings. We can reduce the drying time with optimized parameters and equipment, and this will give us this savings in energy in these drying operations. Talking about additives, we can try to eliminate the coating process, especially for ductile iron castings of automotive components, and this will give us also these savings. And talking about fitting systems, both risers and filters can also help us improving our yield. We can also save some metal, and in the end, we save energy in the melting shop. So now, thank you for your attention. We go now to the Q&A section. So please, you can now post your questions in the chat box if you have not done it yet. And in the meantime, let's read what we have so far. Let's see. We have a question that says, how can I reduce energy with binders? In this case, I think this question is more for you, Reinhard.
Yes. The energy for binders is especially in hot curing processes. You consume a lot of energy, especially gas or electricity. And we have nowadays developed new cold curing binders, which can substitute this hot curing process. So whenever you are interested in this kind of topic, we can make a connection to our binder experts.
Okay, thank you. Let's read another one. What about rework? Can we save it? I guess they're mentioning save energy. About the rework, Reinhard, do you want to add something?
Yes, I mean, rework has also a certain energy consumption, especially, of course, in steel castings. If you want to remove burn-in defects, but also if you have, let's say, in gray iron castings, automotive castings, waning defects which you have to fettle away. This can be eliminated with the right binder and right coating, that you do not have any of these casting defects which you have to rework later on.
Mhm. Okay, we have no context about this question, but maybe thinking about the feeding systems, for example, and the rework. It could be that when we change from traditional fitting solutions to KNV XL risers, for instance, we also have these reduced diameters in the neck area, and this can help us also to reduce this time of rework operations. So let's read another one. What would optimized solid content in coating? Right.
Okay. In general, you have to look on the kind of um, coating you need. For instance, in steel castings, you need high refractoriness. That means you have to have a silicon silicate or alumina-based coatings, maybe in some cases also mullite. For this, I would say if the solid content is in application above 60 degrees, ideally at 60%, ideally at 70%, you certainly have an optimized solid content, which enable you to have a fast drying possibility. And the same is in automotive coatings for cold box, for instance. Here you have to have other filler material because mostly the casting defects are waning or maybe burn on. And this is a kind of different refractory fillers, which as they have a lower solid content. But nevertheless, if you have solid content there of about, I would say, 40% in application, 35 to 40%, you will have in a good condition to save energy.
Mhm. Okay, thank you, Reinhard. So we have one more question so far that says, if I am using your paddings technology, how does it affect affecting the energy savings? So paddings, yeah, we have not talked today about paddings, but it's a good question. As this paddings technology is like an extension of the same riser material, and we can have this kind of exothermic and insulating properties in certain areas of a casting. And one of the main benefits of using paddings is that we can reduce sections of a casting that could have been increased to help the fitting or on certain areas. And the fact of using paddings and substitute this extra material of metal in that area can help us saving a lot of time and energy in the rework operations afterwards. Let's read another question that says, is it suitable for heavy wall castings like 100 to 150 millimeters wall graphite castings, binders particularly? I think this question, I don't know if it is related to the patterns that I was saying, or for the previous coating castings, coating products. But do you think, Reinhardt, coatings are also suitable for
I
this
don't
kind
know.
of?
I mean, what is meant with graphite castings? I mean, is it gray iron casting or?
Yeah, gray iron castings.
Okay. Yeah. Okay. Before it was mentioned that the coating application should be brushing. For brushing, you have of course, the benefit that the solid content is typically the highest compared to all of the other application methods, for instance, dipping, overpouring, or spraying. Um, and here for instance, we have some coatings which even had solid contents up to 75-80%. So these kind of coatings are available, and of course, this will save you energy. But typically, when you apply brush coating, you use torching and you do not have, let's say, um, a drying oven. But maybe you can, if you need to have more detailed information, maybe you can contact us later on.
Yeah. So we have one more question. This time is regarding the risers, and it says the exact cast Kim 4/7 could save more than a standard sleeve by different recipe or same design. So these savings are mainly due to the change in volume. I mean the inner part, the quantity of metal that can have each of the risers is different, and this is only because of this shape change. And the savings are coming mainly from the reduction of this volume and the optimization of the fitting inside. Nothing particularly about the formulation. So in the end, is the wall thickness of the kim that gives to this riser or keeps to this size the same module, having the same performance but with less volume. So I think so far these were all the questions that we received from you. Unless we don't receive something else, then I would say thank you for your interest, and I would also like to remind you our website where you can find all our digital services for you. In our product finder, for example, we can also offer these white papers and technical information. Use our Ask the Expert app and look and see the webinars already done, so you can check it out. So I would say thank you all, and we wish we can see each other in GIFA very soon. Thank you.
Thank you very much.